Welcome. In this video series, we're going to run through an exercise that will involve taking an example GCBM dataset and simulation workflow and reconfiguring and simulating it with a new sample dataset. This will demonstrate the standard process users will employ whenever they want to run a GCBM simulation with their own data. In order to follow along with the steps on your own computer, you will need to download the GCBM software and training components.zip file on Canada's National Forest Information System, available at the link provided in the video description. To start out, make a copy of the whole 1_standalone_template folder and paste it to a location on your computer. Rename the copied folder sample_data_exercise. In the next steps, we will replace the default spatial and aspatial data in the project with alternate sets, something users will eventually do with their own spatial data. Go into sample_data_exercise \layers\raw and delete all of the files. Delete both the disturbances and the inventory folders. The next step is to copy the new spatial data into that layers\raw folder. In the training folder, go into 2_sample_data\spatial and copy the contents. These are the user's new inventory, disturbance events, and mean annual temperature data. Go back into sample_data_exercise \layers\raw and paste in the files. The next thing to do is replace the aspatial input data. In the training folder, go into 2_sample_data \aspatial and copy the yield_curves.csv file. Then, go into sample_data_exercise \input_database and paste in the file. This is the user's new set of growth curves. In the same folder, delete the old yield.csv file. Now we can have a look at our new dataset. To view the format of a GCBM growth curve.csv file, double-click on the yield_curves.csv file. Columns 1 to n represent the classifier or classifiers for each stand. In this example, the file only contains one classifier, LDSPP, an acronym for leading species. The next column, AIDB, or Archive Index Database Species, represents the leading species of the stand, which identifies to the GCBM which species volume to biomass conversion coefficients to apply. Then we have our age-volume pairs in cubic meters per hectare. In this example, the gross merchantable volumes have been entered in 10-year increments, so the first volume column represents the volume at age 0. The next column represents the volume at age 10, and so on. However, the user is at liberty to use whatever increment suits them when preparing their own growthcurve.csv file. We can see that the classifiers link our spatial inventory to the yield table in order to tell the pixels how to grow. For this new sample dataset, we just have a single classifier representing leading species. We can now close the yield_curves.csv file. The inventory import file for the GCBM is spatial, and the stands identified within are linked to the yield_curves.csv file by stand classifier sets. To see how the yield_curves.csv file links up with our inventory shapefile in our new dataset, go into sample_data_exercise \layers\raw\inventory and open the inv_sample.shp shapefile if you have a GIS program. Once the attribute table is open, the first column, Object ID, can be ignored. The second column, Age, represents the age of the stand, which gives the initial age of each polygon at the start of the simulation, and the fourth column, LDSPP, is the leading species classifier representing the stand. This value matches up to the classifier name in the yield_curves.csv file, which is how we make the link between the spatial layer and the yield data. We can now close the inv_sample.shp shapefile. In the next video, we'll demonstrate how to configure and run the tiler.